Thank you very much. It was my great pleasure to chair this session on thorium reactor physics. What wasn't a great pleasure was that it started at 8:30 in the morning after the conference banquet, where I think we were all feeling a little bit worse for wear. So I put up the photographs of the four speakers just to prove that they were awake and ready to talk. So we had a session on thorium reactor physics, but actually it was split into two parts, really. Part was associated with data collection, curation, and management, and the second was devoted to fast reactor physics. The first talk was given by Srinvan Ganesan from BARC, who introduced the nuclear data development related to the thorium-uranium fuel cycles. And in doing so, he introduced the new Center for Nuclear Data Physics in India, which is in fact a virtual center. But even though it's a virtual center, it is clearly doing a lot of really very good work, both in the contribution to the national effort to secure parameters associated with cross-sections and so on, but measuring those cross-sections and curating them, but also contributing to the international databases as well. And it's clear that as India moves forward with its nuclear program, and particularly moves forward both in molten salt reactors, in conventional reactors, and in ADSR systems, that they need these parameters extremely accurately in order to model the systems that they're working on. The second talk was similarly on nuclear data. It was a collection of nuclear data from NTOF here at CERN. NTOF, as you know, is a time-of-flight system based on timing the flight of intense beams of spallation neutrons over a very long distance, and it's providing, I think it's true to say, some of the most accurate cross-section work that we have available at the moment, and we can collect that data in a number of ways. The first phase was with a relatively simple spallation target between 2001 and 2004, and then this was modified in 2008 with a much more sophisticated water-cooled target, again producing excellent results. And what we were also told about is that we're about to move into the third phase of NTOF, where they're taking a second beam vertically out of the spallation target. This is a much shorter flight path, therefore with a much lower resolution, but correspondingly has much higher intensities, and therefore will be extremely useful for measuring cross-sections of short-lived isotopes. The third talk by Konstantin Metikyuk from PSI was on fast reactor physics. In this talk, he introduced the gas-cooled reactor, the sodium-cooled reactor, and the lead-cooled reactor. He then focused principally on the sodium-cooled reactor and compared the uranium and the thorium fuel cycles in those two reactors, and found that there were significant advantages of the thorium fuel cycle in terms of the production of minor actinides, reactivity, and so on. But he also found there were substantial disadvantages as well. And I think that the conclusion from this talk is that if you were going to build a sodium fast breeder reactor, you wouldn't actually fuel it with thorium, but with uranium and plutonium instead. So that then takes us on to the final talk of the session, which was Elsa Merrill-Lecotte, whose work was also discussed in the earlier session when Rob Arnold presented the UK strategy on thorium deployment. And this, to my mind, was probably one of the best talks at the conference. It was the most detailed. It was the most far-seeing in the development of molten salt reactors and molten salt fast reactors in particular. Elsa went through almost every aspect of the EVOL program to develop a fast molten salt reactor, considering issues such as safety, fluid flow within the material, the chemistry and the material science that goes into building a reactor of this sort. And I think the message that came from that is that we can all play with little systems on paper, but when you do a complete survey of a facility like this It highlights some principal advantages, but it also highlights some difficulties which we need to address in research programs. So to summarize the session, the conclusions were that we obviously want to move the thorium agenda forward, but to move that agenda forward, we've got to continue the international effort to measure, refine, and curate nuclear data related to the thorium cycle. It was clear from the first talks in the session that there are gaps in that. I mean, for example, it's only just recently that the protactinium 23-2NF cross-section has been measured in India, and that's absolutely fundamental, I think, to the deployment of thorium fuel. That data has to be curated well, it has to be accurate, and it has to be available for anybody who's developing a thorium system. Secondly, we want what I call the deep modeling of the whole thorium-fueled reactor system, whether it's an ADSR, a conventional reactor, a fast molten salt reactor, or just a conventional molten salt reactor. That deep modeling is absolutely essential, and I think it's very easy for us to all claim that our own chosen technology is the best one that's available for the deployment of thorium. And in doing that, we tend to gloss over the problems. And I think that this sort of modeling actually highlights those problems and gives us the motivation for trying to solve them. And of course, these two things are intimately linked, that you can't do the second unless you've got the first. And that leads us to the final point, and that is that we need a willingness to accept or reject appropriate or inappropriate thorium deployment scenarios based upon real evidence provided by both the data that we've collected and the modeling that stems from that data. Thank you.
Thank you, Robert. So Bob is ready to take some questions. Yes, please. State your name.
My name is Sebastian Besta. I am from Royal Institute of Technology from Stockholm, and I am working in nuclear power safety. So I have a comment for the last presentation regarding the safety issues. And it seems that we are considering the safety of liquid metal salt reactor from a little bit surface way, and we need more detailed safety analysis. Because, first of all, in this concept, we actually excluded two first safety barriers, fuel matrix and clad. And we need to have something more if we do not have these two first barriers. Also, we should think about a kind of secondary shutdown, independent shutdown system for the reactor. So I think we need more work for the safety of liquid metal salt reactor. Thank you.
Yeah, thank you.
If I could just answer that. Yes, I mean, I think that what we have to bear in mind is that the EVOL program was extensive, and it was a 30-minute talk, and some issues of safety were touched on. But I suspect I'm not an apologist for that program, but if Elsa is here, I'm sure she'll discuss the safety issues with you in more detail.
Yes, please.
EG PSI. I have a comment related to that question. That's fully true. We need such a safety analysis. We may need the same safety analysis also for ADS. And because nothing is perfect, I would like to ask if at least we can agree here that both these systems will need at least reduced containment. So not full containment as the light water reactors, but both MSR and ADS will need at least reduced containment. Is there at least agreement on this
Yes.
question?
Yes, I don't see why ADS should need reduced containment.
We have already designed, built, and licensed a first ADS with lead in front of the Belgian licensing authority. Indeed, you need safety studies to license any nuclear facility. Not more, not less than any other system. We are preparing the licensing of Mira 100 megawatt ADS. It is not we are playing alone in our offices. It's with the licensing authority with whom We have put a pre-licensing trajectory for this project with a series of studies and experiments in support of this, which are already running. I can tell you that we are going to make transient on the fuel of Mira in a pulsed reactor, because we have to put that in front of the licensing. So, I mean, you should not, think that we are joking. Sometimes we have to stay realistic, we know, but we are doing the job correctly. And I think we have not to say that, well, like if those guys are simply dreamers, I think they are addressing the key question correctly.
Yeah. Thank you, Amit.
Could I just add to that one of the things that I think we've probably missed out on at this conference is a talk by the licensing authorities themselves. I would love to know what we do to move forward the licensing issues with almost all of the new systems that we've discussed at this meeting. I had a rather bizarre conversation at one stage, and it went something like, I would like to know how to license an accelerator-driven subcritical system. And the answer was, well, we can't license it. And when I asked why, they said, well, because we haven't built one.
Yeah, I will tell you...
And that seems to be the conversation.
No, but these are when we are speaking theory. But when you have a licensing authority who has to do the job, and where you have a project on the table that has to do the licensing, people of the licensing are also rational people, able to think with you, as long as you are considering their questions as rational ones. From the point of view of the licensing, they have to care about the safety and security of the population. You have to care about the operation of your system and a safe operation. You are also not willing that that facility that you are building, the first responsible of safety or security of a facility is the operator, actually. That's right. And so I think we have done a pre-licensing trajectory for Guinevere. We have done a pre-licensing trajectory with our licensing authority for Mira, and this is working in perfect harmony, and they are willing to license it. They said, as we have to fulfill a certain number of studies to get to the first authorization that this will be licensed in this country, and we are doing the job.
Okay.
Am I right in assuming that the licensing is progressive and that you've been given the steps that you have to go through?
Yes, yeah. And there have also rules, and the WENRA rules are the one we are following for the Mira.
Thank you, Amit. I think we all agree that ADS has gone a much longer way towards licensing than molten salt systems.
Can I make a very quick comment? Are you looking? Yeah.
Yes.
Just a very quick comment. I think this discussion, which was very interesting on safety, I fully agree with what's said by Hamid. This kind of exchange results, I think, from the fact that some people, not that many, fortunately, claim that ADS is zero-risk facility. It was written on one of the slides. When you see that on the newspaper, when you say that for the man in the street, zero-risk facility, you find this kind of discussion. Do you need a containment or not? Of course we need. You will never license any nuclear facility without a containment. That's evident. Even if you say this is a zero-risk facility, yes. It's impossible.
Okay, but thank you very much.